Today is Tuesday, April the 23rd, and this is the first video for AEP, and we're trying to show the 2100 firing board. And we have here an anti-pair of SCRs. We have a single phase AC controller where we have the line coming in at 243, and we have the output of that AC controller going into a lamp load. Right now we have no output, and although the board, can we enable the board, Tony? Okay, we have the board enabled, but SIG high being 0, and there's a low signal, inhibit signal, that it's not until that SIG high or voltage command signal gets to a certain threshold, about half a volt, we won't get any output. So I'm going to ask Tony to increase SIG high until we clear that red LED. Alright, wait right there. At that moment we're starting to see some output, and I'm going to ask you to start increasing SIG high now, Tony. So this is phase angle control. We see the delay angle being less and less to the point that now we have a nice sinusoidal output waveform, just like the way it would be on the input. At this point we have 242 volts AC on the input and 241 volts AC on the output, and we can see that the lamp load is turning on, so the board is ready to go. Now this is the issue as far as your application is in regards to the board. Now everything's working okay. Can you bring SIG high again, Tony? I mean, this board could work if SIG high was at the maximum, otherwise you won't get your full waveform. That's one of the issues, but that wouldn't be a problem if we bring in SIG high to the maximum. Let's go ahead and do that, Tony. And here we're gonna take a single shot. So can you inhibit, Tony? I'm gonna go now with a single shot, and we're gonna look at the enabling, and we can see that here this board enables basically at any given time randomly. It's just when the customer commands the board to enable. In this particular case we are actually close to the 90 degrees, but if we try it a couple more times, we can see that you can come in with the voltages actually on the negative. Alright, see, same idea. Now the last thing that I want to point out on this video is, and again this just happens to be random. Go ahead, Tony. We're going to open up, this is 10 milliseconds, so we're going to open up our time scale here to 1 millisecond. I'm going to run it one more time. And here we can see the bouncing and debouncing on our switch. But we can see here that, go ahead, Tony, there's hardly no delay, no visible delay at 1 millisecond per division. Oh God, Tony. Yeah, so again, it seems that it took this much even before the debouncing of the switch, before the board actually started getting an output. So this right here, it's the 2100 board, and again this board wouldn't work because it will not guarantee that you always get that you start conducting when you have the maximum output. Now we have a different board. It's going to be the CVTC that it's basically the same principle, it's just a simpler board, and we'll notice that that's DC gating, and that DC gating will fire the board per your application when you command it to enable, and all we want to show is just the delay between when the board is enabled to the time that we get an output from the AC controller. So this is the end of this first video.